Okay, to get started, thank you everyone for joining. I do have the chat window open. If anybody has any questions, feel free to ask. And the subject of today's chat is Apache Nifi, which is a drag and drop approach to data processing on the cloud. Today, we're going to be doing a little bit of a what Apache Nifi is used for, a review of some of the core concepts, a review of how some people have actually used it, and then some practical examples with a live demo. I expect that last part to be pretty open to requests and people to ask questions. I'm more than happy to take some time and demo specific functionality if you have a specific question. But what is Apache Nifi and what is it? So it's an open source product covered under the Apache license, which means it's completely free to use and remix however you want. Some people, such as Calculated Systems and a few other people, provide distributions and value added on top of it. But at the very start, you're able to download it from the Apache website for free. And basically, it's an approach to data processing that makes it more approachable. It enables you to do things such as drag and drop functionality, where you can drag in processors, they're called. I'll review that in a moment, to complete different preset actions. There's hundreds of processors, and it's also expandable with scripting. But what one of the main goals is it allows you to start using the data and to start processing events without having to learn a new framework or even a new language. It avoids the problems of having to do things like having to learn Python functionalities or Java functionalities or Scala, and it allows you to get started immediately. And an important thing to understand as we go through this is that this is an event-centric view of the data. This means that we view data as a series of events. Maybe an event would be a new log line being added to a file, or maybe a specific HTTP call gets made. And even we could do something like a time-based event. The point is that Nifi takes a view of the data where it gets triggered by something. This is different than other things such as SAP and Oracle's integrators, where it's more of a table-centric view, and it's then waiting for you to query it, and it'll handle the data. What this does is it takes the new event, processes it, and brings it all the way through the end. So what are some real-world use cases of how people are using this? This is a picture from one of the videos we made at the LA Auto Show of a Jaguar that was using Nifi. I can explain more in detail. In fact, I actually have rights to share the entire source that we used for this, so I'll show that later. But basically, the car would make real-time calls to a Nifi instance. Nifi would then process the event, process the data, and send a command back to it. In the auto show, you can even see the computer in the background. We were simulating a car driving through different weather conditions and having the windows and roof go up and down, responding to it. Where Nifi was taking in the GPS and what data, enriching it with the weather, and sending a command back. Another one, just for those of you who are more technical on the call, would be this factory floor architecture diagram we did with Azure, where we have different machines. They are all making log files, XMLs being put in a directory. A Nifi centralized agent is monitoring those directories and uploading the events line by line to Azure Event Hubs, which is a simple message queue. And then we're processing it through functions and basically making an alert if the scrap rate is high. This is what we did at an automotive OEM, and we were able to alert them on scrap rates automatically, where if you think about it, a part being completed is the event, and then we are enriching it and processing the data, looking for higher than normal scrap rates. I do have the questions open here. If anybody has any questions, feel free to raise your hand or and ask in chat. But the main point I'm trying to show here is that Nifi is able to operate in both an agent capacity to monitor for events or in a cloud capacity, where we make it available on Amazon, and it is also available on Google or basically anywhere you can get an instance to run it. We have run Nifi on everything, or people have run Nifi on everything from as small as a Raspberry Pi up through a 32-core server. So let's start digging into one last use case that I'm actually going to show a bit of a live demo for later, and then we'll start going through some more practical examples. So one more thing Nifi is able to do that's rather interesting is replace legacy ETL by changing how you think about it. Basically, we worked with a financial services company that had a Bloomberg data feed. And for those of you unfamiliar with this, it will have something like 10, 20 different funds, which are just financial products, available in it. And what Nifi is able to do is break those up into separate streams, which then process in parallel. That enables you to allow each fund or each division a separate department, a separate amount of processing so that they're able to look at the data independently and not impact each other. This is to be separated from some more classic monolithic forms of ETL. But let's get into a little more practical about what Apache Nifi looks like. So this is the concept of a flow. I took a screenshot and I actually put these blue boxes over it, and I'll reveal what they are momentarily. But at the most basic level, you have the retrieve, to read a file and to save a file. So basically, we made a file movement system. We have a processor that will retrieve the files. That was drag and dropped in. We have a processor that will save, or as Nifi calls it, put the files. And that's another drag and drop processor. And then we have what they call a connector. And I am able to click and drag the retrieve file once, drop it onto here, and tell it to send the results. I will be live demoing this later. But let's look at what these are. So get file. A few things you should look at here. And I understand that this is a demo, so there is none being read or write in the static image, as you may imagine. But Nifi is able to tell us a few things. First, it's read in 0 bytes. It's put out 0 bytes, and that it's checked for files 0 times. I will be doing a live demo with S3 later where you'll be able to see these. But just know that whenever you see a processor, the main parts you need to look for are the name, which is just a get file, the stats on how it's running, and the errors. It's an error because it's not set up because it's just a static image right now. Then the destination, put file. Same thing, you can configure it, which I'll show in a moment. But once again, it's just another processor. And then for success. Now this connection is for a success condition. There's other conditions. Maybe a processor that looks for text analysis might have a condition called match found. Or maybe if it's a type of processing step that could have an error, there'll be a failure queue. But in this, the concepts to know that our processors, these are predefined actions. These do everything from get the file, to put the file, to parse the file, to even things like SQL lookups or REST API calls. But these are just predefined action groups that can be dragged and dropped. Some processors even enable you to do things like write custom code. There's things like Python and Java supported in processors, and you can always make your own processors as well. It's an open source framework. It's very expandable. I've noticed most use cases can be accomplished with just the default action groups though. So that's processors. Connections are how different processors relate. These have things such as which processor does it go to? What type of event should flow to each one, a failure or a success? And they even have the concept of back pressure. So I can show you in a little bit how a connector could start to give feedback back up the chain in the event of a failure. And then flow files. A flow file is simply what we call an event that is a combination of its metadata and payload. So if you may imagine in our previous example, get file, put file, the flow file would be a piece, would be what we call what goes between them, and it would contain metadata such as the name, when it was read, and stuff like that. And the payload, of course, would be the file. So processors connect to other processors with connections, and flow files travel between them. So whenever we look at a Nifi processor, we might need to configure certain things, such as where does get file get its files from, where does put file put its files to. This can be accomplished in the configuration section, which you can get to by right-clicking it, and it enables you to do all the settings you may imagine. Once again, expandable. But here we have an input directory, we have a eliciting strategy. A lot of these come filled out by default. Some of them are optional, but very importantly, you might notice some of them enable things like expression language. Nifi allows you to use a flow file's metadata to fill in the next processor's configuration, which I'll also demo, but just know that every processor can be configured to have a customized set of settings. So let's look at a sample pattern that's important. A sample pattern that you might do with Nifi, just to start giving you an idea, and once again, I am open to questions if people have specific asks, are we need to enrich an event that comes in. You have a Kafka message, you have an Amazon Simple Queue Service message, you have an Event Hubs message. You need to take that message, you need to parse it. You then need to do a lookup against a database to like maybe fill in the serial number or fill in the machine's easy to read name, and then alert on it. So a pattern that would look like that would start like this. And please tell me if people are having trouble seeing this due to just how the screen share works. We can make it larger. So we have a drag and drop processor for consume Kafka. There's a few different ways to consume from Kafka. This is the most basic. It's simply saying, read from this topic and make a flow file based on every event. These flow files will have different pieces of metadata, such as topics, such as information, but very importantly, out of the box, it doesn't know what to do with the payload. So we need to write a little bit of a function called extract text, which once again is a drag and drop processor. It uses some standard regex if you want to get fancy, and that allows you to do that. We could then execute SQL, or more typically, against this example, would be a attributes to JSON processor. So, or sorry, attributes to SQL processor. So we have different options. In this example, we're simply executing 2 SQL queries and using the results to execute the next one to show them to be chained together. But do know that we can use combinations of extract text and stuff to make complex SQL queries that have variables that can help process them. But I want to show another key important fact here. You might think that these flows get very complex as they grow. And this brings us to the concept of a processor group. So going from this, as you may see, execute SQL, coming out of this last execute SQL, I want to show how we can show abstraction and even version control. So I am going to say, instead of just terminating on this execute SQL, we are going to have it go to what's called an output port. Now, output ports are important because they are how processor groups communicate to each other. So all the processors that I've shown so far can be hidden away, or I don't want to say hidden away, I could say be combined into what you might want to call a class, but I know the comp sci people on this call would slap me if I called it that. But basically, all of those processors can be put into this execute SQL demo processor group. And you can see we have 5 processors in there, or 4 plus the output port. And this can be independently version controlled, templated, and even monitored. And we can even set permissions on this. So maybe we want to enable one team to have access to the execute SQL processor group, and we want another team to have access to the reporting processor group. It enables us to separate and control who has access to what. And by defining the output port, it enables the processor group people to very carefully and control what they can have as inputs and outputs for teams to be able to interact with each other. In my previous mentioned example about the financial services firm, they basically were enabling different teams to process their funds separately without impacting each other. So you may imagine the IT department is able to set up a centralized one, and then each group from there would have a processor group. And then, of course, processor groups can hold other processor groups. You can have as much recursion as you want. But my point is it allows for resource isolation and controlled and standardized inputs and outputs and version control. And then once it's all set up, it allows you to once again just connect it to any other processor as if it was a default option. Another major capability is the ability to operate as things such as a REST API server. Basically, we're able to listen for a GET or a POST and then treat it like an event. Of course, things like options are also available, but I'm just going to focus on those two for now. This is really good for stuff like IoT applications or even internal tooling. The Jaguar demo that I showed previously really took advantage of the REST API server and used it for all of its inbound and outbound communications. It's also really good because web dashboards can be based on this, which makes it a great option for internal tooling. So a super simple variant of this would be, we're going to take an incoming HTTP request. We're going to look at the text and maybe replace some of it, and then put a response in and to the client. Now, there's a few things I want to point out on this screen that's going on. Importantly, this doesn't do very much to the thing. All we're doing here is replacing the text in a post, basically. So the post is going to be created. Its headers and its origin information will be stored as flow file metadata. The replace text processor is going to simply replace the payload or what was posted with whatever text you want, and then it's going to respond. Now, a few things here too to note. By separating the request and response processors like this, we actually enable it to time out if there's an error. The response will only get to the end user if it's able to accomplish an end-to-end flow. So this enables us to do things like routing and error handling. In fact, one way that we could improve this flow or modify this flow is to put a second HTTP response handler on the failure queue. This will enable us to give something like a 500 or a 403 error in the event that we're not able to process the request. Simply, right now, this one fails silently. In the live demo, I'll show the concept of controller services. It allows us to communicate which processors work with which other processors for HTTP REST requests, but in their most basic state, assume any request can be handled by any response. Another silly feature that took me forever to realize is if you are using Nifi, you can put L's and kinks in your in your connectors by simply double clicking on the black section, and it gives you an elbow. It took me an unreasonable amount of time when I was first learning to realize how to do that. There's one other very important thing I want to point out, and that is the funnel. If you notice, replace text at the bottom was connected to this little blank thing. This is called a funnel, and we're using it to capture all failures. Now, funnels are designed to combine multiple flows. For example, if you have lots of processors with lots of failure options, we can send them all to a funnel and have them all go out along the same pipeline. That's super good in production, but it's also super useful for debugging. A funnel is a simple, easy to drag in endpoint. They are able to send events. Now, this might be troublesome in production because unless we add a clause for this failure queue to empty itself out, it might fill up and start storing a lot of data over time. We could configure to auto drain, but just in debugging, it's super great to have something just to drag it in and show. And I now want to spend a good amount of time showing some live demos of Nifi and really walk through how we're going to build a flow. Nifi is great because it enables you to basically to whiteboard as your demo. There's not much code on screen. There's not much syntax errors by comparison. So what we're able to do is kind of communicatively build out an idea. I assume everybody could still see my screen. Please tell me in chat if there is a problem. So what we have here is the Nifi canvas. That's just what this blank space is called. You can see over here I have a few processor groups from previous demos. We're going to ignore those for now. And what we are going to do is drag in a processor. So if you're looking to use Nifi, your first steps are always going to be install it on your own system. Calculated Systems does have an Amazon Marketplace distribution that enables you to spin it up without having to worry about coding and SSH. There'll be a link to that later, but you don't have to use that. At the very least, you're just going to use this processor, Nifi. It'll look like this. You can connect to it over Amazon. I did password protect my demo. I've learned from the past. And what we're going to do is in the top left, we can see what we're able to drag in. You have processors, input, output, processor groups, funnels, and templates and stuff. So what I'm going to do is drag in a processor. Now you can see there's almost 300 processors out of the box. They have the name, the version, the tags. The version is important because it allows you to have multiple versions of the same processor just to support legacy code and applications. But I want to read some files from S3. So I'm going to type in S3, and I'm going to see that I have a few options. So I want to list an S3 bucket. I set up a demo bucket from S3. It has a bunch of sample files, and I'm just going to show how we can read this, how we can process this, and get through it. So as you may see, there's nothing coming in and out of it. What I'm going to do is now drag in a funnel just for debugging purposes. And then I'm going to click and drag a connection. Now, when you click a connection, you'll get the create connection dialog. There's only one relationship that comes out of S3. It's for success. That's because if it fails, you just won't get a message and you'll instead get some errors, which I can walk through later. But now I need to configure it. I need to tell it what bucket and what credentials to use. Now, when I go to right click it and hit configure, I get this pop-up. I can rename the processor, which I'll simply do to read from S3 webinar. And then I'm going to go to properties. In properties, you can see lots of options. We're going to use a bucket name, which I'm just going to copy over from my other page. This is password protected though, so we need to tell it how to get into there. Now, this is another area where Nifi really starts to excel because we don't actually need to distribute a credential file to all of the users. We could, if we wanted, enable people to use their own access keys, but what we're also able to do is what's called a credential provider service. This is something I haven't touched on yet, and it's basically a way for a centralized IT department or administrator to provide standardized credentials to all of their processors. To take a minute to look at this, I can just click this. Yes, I want to save my changes. And you can see all of my controller services. There's only one right now. And if I was to click over here on the right, I could view its configuration. And I could see that I have sensitive values set for access key and secret access key. The cool thing here is if I need to update or change how I am how I am authorizing my application, I could use this service to quickly deactivate or change the keys to everything. Also, we could use credential files as well to keep it even more remote and version controlled. But for this demo, we simply use this controller service. So to close out of the controller service, go back to where I was, you could see I set the AWS provider service to that, Nifi demo bucket in US East. Everything else could be set, such as proxies, but we're not going to worry about that right now. Hit apply. Now you may note it's all started up, but it's not running yet. Nifi processors really have three states they could be in. They could be in running, stopped, or error mode. To start it, there's a few ways to do it. I'm just going to do this one by right-clicking and hit start. Now, the Nifi canvas automatically refreshes every 30 seconds to show you what's on screen. This can be frustrating to wait for, particularly if you're doing a live demo and everyone's watching. So what you're able to actually do is right-click anywhere on the screen and hit refresh, and it'll forcibly refresh all the values. And as you can see, every time I refresh, the tasks go up. So we found 79 files in the S3 bucket. That's good because there are 79 files in there. Now a few things happened. We have all of the files in the queue. These flow files though, let's look at what we grabbed. Nifi gives you the ability to inspect, or I think the right word is interrogate, but that sounds a little violent, inspect what is in a queue. So if you right click it, you can even hit list queue. And what you'll see here is some very interesting things. So first things first, let me zoom in a little. We have the order. Nifi queues are ordered. Ordering is not necessarily guaranteed, but it's there. We have the file name. As you can see, I just used a ton of images used to make Nifi for this bucket. I literally just took all of the JPEGs out of default Nifi and put them in a bucket. Now you might be thinking, why is the file size 0 bytes? It's because all we did is list the files in this one. We didn't tell to actually pick them up. This is good because it allows us to selectively pick when we do things like read. Let me show you one step further. I'm going to hit view details on the first one. This allows me to individually inspect the events as they come through, which is great for debugging or even anomaly analysis. So I'm going to go to attributes, and you can see lots of attributes. You can see where we pulled it from, the S3 owner, and most importantly, this S3 bucket attribute. I'm actually going to copy this, and I'll show you why right now. So what I want to do now is actually get the files. All we did was list them. So once again, I'm going to drag in a new processor, and I'm going to say fetch S3 object. Now, when I go to configure this processor, you'll notice a few things. First, I'm going to set the region to be US East. I'm going to give it the provider service we set up, but bucket. You might think we have to put in our Nifi demo bucket value here, which would make this difficult to maintain, particularly if we want this to fetch objects from multiple buckets. But what I'm going to do is use the Nifi expression language here. You can see it right here. The object key automatically filled in to be file name. Here, let me zoom in a little. The file name. So what I'm going to do is simply $, open squiggly, S3 bucket, close. What this will do is it will try, or it will, not just try, it will do, to pull in that attribute from any flow file that comes to it. This enables us to make programmatic things where it will roll down. As you may imagine, we might have multiple buckets being read that we want to fetch. This is great because it allows expandability and programmatic access. Hit apply, zoom back out. Now, we could, in theory, drag another connection just like this from read S3 to webinar, but I want to preserve these found files. I'm going to click the processor, the blue one, and I'm simply going to connect it over to here. This is interesting because what it allows you to do is stop a processor, let the events queue up, and then drag it over to a new one. It's an interesting way to do a cutover using manual operations. That can be used in production. Everything you're seeing on screen is completely scriptable if you really need a robust way of running at scale and you don't feel comfortable having an operator do an event cutover. But for small and mid-sized businesses, it's absolutely a great option to just simply drag in a new processor group and connect it up to the existing ones like that. All great options. So you might wonder, why is this still in an error state? Well, it's because we have two different connections that we need to handle. So I'm going to be a little lazy and just drag in two more funnels. And I'm going to drag and drop it to here. I'm going to say for relationship success, you go this way. And for relationship failure, you go this way. I'm actually going to zoom back out and just to reset to normal and then zoom back in. There we go. Any questions so far? We do have chat if anybody has questions. But going forward, I'm now going to turn on this processor, right click to refresh, and you can see it's streaming the events through. And more importantly, you can see, or very importantly, you can see it read in 0 bytes, but output 6.67 megabytes. So it successfully read them in. I could inspect it, but I actually want to show one more thing first. I want to show how NiFi can handle filtering and routing of events. So what we're going to do for that is pull in one more and look for a route option. So we're going to route on attribute. I want to filter processors or pictures based on their name. So simply I'm going to connect it here. I am going to send all failures to the, actually I have to set the rule first before I define a failure. And now I'm going to right click this and hit configure. So routing strategy, route on property to name. So this might be a little confusing. At first when I did it, I wasn't sure how to add routing rules. And all you do to add a new routing rule is you click here. And we're going to name this contains word allow. And what I'm going to do here is just write some expression language, file name, colon, contains, allow. This allows you to do simple functions where maybe a drag and drop functionality isn't quite enough, but this is a far cry from having to actually do coding. So if I hit OK, I hit apply, I'm now going to drag the outputs from this. So first things first, drag a success processor for relationships contains word allow. As you saw, we just made that routing rule, and I am going to route based on that. And now, of course, we need to handle what happens if it doesn't contain the word allow, which is unmatched. Now, I'm going to run this. I'm going to refresh. And you can see I found the one processor that has the word allow. Let's look into that for a moment. Okay, I'm going to hit here. It's a processor that's called allow weak crypto. I want to look at what this actually is. So as I said, a payload is a combination of metadata and the payload. So if I look here, I can hit view, and it seems to be a picture from the user manual that highlights that you're able to set bad or low, I don't want to call them bad, low security algorithms in some of your processors, and to even forbid them. So that's a cool way to handle routing. Now, a few more ways to clean this up. I'm able to stop all the processors just by right-clicking on empty space and hitting stop, or hitting something from over here called stop. Now let's say I wanted to clean this up for production a little bit more. You might be worried that this number of queued events could just build up as I keep reading in more and more. Well, there's a few ways I could do that. First things first, I could say that the flow files in this queue expire after a certain number of seconds or minutes. I could also say there's a limit of 100 files in here. So watch this. When I say that, you might see that this queue is now almost completely full. That means if it hits 100 files, it'll actually stop accepting new ones, which could completely back up your flow. Now, this could be really bad, and you probably shouldn't do this in some cases, but in other cases, this allows for back off of upstream processors in the event that a downstream processor is getting completely overwhelmed. A great example of this is if you're making external database calls and the database starts getting backed up, this enables your NiFi to start backing off that database to allow it to try to catch up before hammering it even more. But I actually want to say we're in production. I don't care about unmatched events. I'm confident my code works. I don't need an error queue. So what I'm going to do is delete these two queues, right-click on each of these processors, and say automatically terminate relationship. So anything that goes to the failure or unmatched queue is simply being dumped. So now we have a processor or a flow that has everything and allows you to then output the events. Let me show you a few more things though. So if I want to restart and redo my entire flow, I might want to reread from S3. If I hit start, nothing happens. This is because NiFi has concepts such as save state. So if I stop it, view state, I can actually clear the state from a processor to restart. And as you noticed, once again, we get 79, and this processors now have 2 because we processed the same event twice. NiFi has things like dedupe protection and all of that other stuff that you could add, but in the most simplistic flow, this is how it works. Now there's a few other concepts I mentioned that I want to make a little more visible. And first is templatizing. I know for larger companies, or even mid and small size companies, but particularly large companies, version control is key. We need to be able to reliably deploy the same exact thing every single time. So what I'm able to do is make a template of this by simply clicking it all and clicking this Create Template button. I'll call this Webinar Live Demo 1. What this does is it makes a template. And now templates can be accessed a few ways. First, I can always drag and drop in my template. As you can see, it's right here. And hit Add, and now we have an equal flow. I need to look into the provider service to reactivate it for these new ones, but we have a template. I could also go over here to this hamburger menu in the top right and go to templates here. And this allows you to see all of the templates. As you can see, I imported an older flow, and I can also download it. This can all be programmatic, but it's very important to know that everything I'm showing you here is expressible as an XML for version controlling. So there's about 15 minutes left in this webinar. What I was going to now do is show a few more advanced functionalities and walk you through how we did a real-world use case. If anyone has any specific requests, I'm more than happy to pause and address those. But otherwise, I'm actually going to show the Jaguar Land Rover demo as was run on the floor of the LA Auto Show, or at least walk you through the flow. We unfortunately don't still have access to the car, so the live demo is kind of on pause, but I want to walk you through how we handled the events and how you could see some separation. So we basically started with four processor groups. Ingest to land data from the vehicle. Retrieve specific, which is how the car or other web services could query its state. The ODS controller, which is the operational data store controller, which is how we processed events and really started to parse them. And roof controllers, which is how we took commands for the roof. So let me show you what the live demo we showed did. So as you can see here, we have a few processor groups, but let me start here. This is a straightforward flow that took in requests coming from the vehicle in real time. So first we have an incoming HTTP processor request, as we talked about. And then we had a processor for checking the token. So as this was a demo, we wanted it to be easily modifiable. We didn't set up a full password authentication. We simply shared a secret key and checked on that. If we didn't get the right key, we sent it to 403 invalid and unmatched. What this allows us to do is immediately short circuit any unauthorized requests while dedicating minimal amounts of computing to them. Nifi is able to handle things such as multi-routing. Now, if it was a good header, we immediately sent back a 200 response, which means your request is great, we accepted it. A few more things, though, to think about. We then said, okay, it's a valid authenticated request, send it down the pipe. And then we also, every 5 minutes, took all of the incoming requests, merged them up into a flow file, timestamped it, put it in a zip file, and stored it in a Hadoop system. This could also be S3, this could also be Azure Blob Storage, Google Cloud Storage, but in this case, we stored it in a Hadoop system. An interesting design choice we made here was to immediately accept or reject the message. Once we send a 200 request back, we don't really have any more ability to influence that request to the requester. So what we said here is it's more important for us to accept the request and figure out what it contains later and then check it for errors later than it was to do error checking up front. As you may imagine, I could put in a parsing processor in here to check that the request is well formed, requires a little extra compute power, but might add more robustness. But if we go to where this one is, we can right click it, hit view downstream. We could see that it's going to the Kafka stream publisher, which if I leave this group, you could see here. So this one is pretty straightforward. We are simply taking all of the incoming requests, updating their attribute. If I go to configure, you could see I'm simply adding a topic, an attribute called Kafka topic, and it's called remote vehicle interface JSON. All we're doing is adding an attribute here, but what that enables us to do in the Kafka processor is do things such as name it a variable. So this enables us to have an expandable ability and an expandable framework where if we were to add more processors and more types of vehicles and more types of interfaces, we can send it to the same Kafka processor. That enables one user or one department to control this centralized topic or centralized processor or processing group while sending multiple events to it. Now, let me show you a little bit more. So we didn't necessarily have to go to Kafka. That was a design choice because we were making the events available to more than just Nifi. There's no reason we even had to do that. But Kafka is great because it has great interfaces to things like Spark and Databricks, which is what we were making this available for. So let's take some more time and look at this. This gets a little complex. I'm not going to go through the whole thing, but I really just want to walk you through what you can do when you really start getting complex. We're able to do things like evaluate the JSON to extract metadata. We then separated a signal processing one here. And what we did here is we did a lot of really complex transformations. The vehicle was not sending clean data. And what we're able to do is do remapping arrays. We're able to split the JSON into multiple events and even extract variable names. All of this led up to us being able to store it in HBase. We could also use DynamoDB, but basically we went down and eventually we're able to store the events in HBase. And we were able to do things like configure, this is not a good one. We were able to do things that get slightly more complex in the code, such as encode it in base 64. We're able to do things like format a relatively complex REST request. And all of this becomes, I don't say easy to do, but straightforward to do. The last thing I want to show, just on this demo, then we'll stop and call it a day or pause for some questions, is just show you how I made a call against an external API, because that's a very important ability. I showed some SQL patterns. I haven't shown any API patterns. So all that comes out of here is latitude and longitude can come in, and then we evaluate the JSON. Let me just show you what this looks like. Nifi supports the JSON expression language, or JPath it's called. All it is $, and then the path to the value. So cells, public, latitude, and longitude. And then I could put those requests in an API call. So as you can see here, we are using those variables in an API call to enrich off an external service. This is really cool because it allows us to take the incoming events, parse it, run it through everything, and then even enrich it. So once again, an event-centric view of the world. There is a YouTube video that I could send out to people if they're interested that shows this in a more complete demo. Take about 7 minutes and actually show it working live with the car. But to go back to the regularly scheduled webinar stuff. So if you want to get started with Apache Nifi, there's really 2 ways to do it. You could always download it from the open source edition. This is just available. It's available to run on your any machine you want. But Calculated Systems, the company I'm from, we also have it as a marketplace image. This can be spun up on Amazon's EC2 instances, and it enables you to just get started out of the box without having to do any of the things like JVM or log configuring that you might expect from an open source edition. We really just tried to make it simple to use, but you are getting, you can start either way. And with that, a few upcoming classes to be aware of is there is a blockchain overview tomorrow. There is actually 2 courses coming up on blockchain. And later this month, there's an agile agile coaching course that talks about what the next 5 to 10 years of agile coaching might look like, or agile development might look like. And with that, does anybody have any questions? My contact information is on screen if you want to reach out to me. Otherwise, thank you all for attending. I'll be around for about 10 minutes if people want to ask or reach out to me. We have a question in chat. It is, how can you monitor and alert on failures on a workflow or individual operator within? So let me actually switch back to the demo and I can show that. I actually rehearsed my demo to not have errors, but yeah, let's induce an error and I'll show you what happens. First, I'm going to leave this demo and go over to my new thing. So here, let's actually misconfigure this on purpose just to show what happens. I'm going to hit configure. I'm going to name, I'm going to typo the bucket. And I'm going to hit apply, and I'm going to hit view state and clear it. So when I do this, it should throw an error that it's not able to pull the data. So here, you might notice nothing came out, and importantly, a few things happened. First, I got this type of error. Now, this is great to hover over it, but this is a little difficult to do. So if I also go here, I can go to bulletin board, and I can actually get a list of all processors across my code. And here, we can even drill down into this and say, failed to process session, bucket does not exist, and it's auto-refreshing. We can export this if we needed. Another way to think about errors is, what if the processor works, but it's a handled error, so it would go to a failure queue. So once again, let's restart this processor. For this next part, let's actually consider an unmatched event a failure. So what I'm going to do is catch a funnel, go to failure, unmatched, and then here. So what do we do with these? Well, I could do something like message queue it. I could put it in a message queue. What we were doing in, here we go, 1 second, sharing my screen still. What we were doing in this architecture over here is we were actually handling everything. But when an error happened, we would send it to Trello to send a text message to the operators. That was quickly replaced by a message queue because there were a high number of failures in the machines, not in Nifi. But it really depends on what you want to consider an error. Is an error when a processor fails and there's a configuration error, like the bucket doesn't exist? Or is an error something like an unmatched event or an anomalous event, at which point we can send it to a message queue? Did that answer your question? Excellent. The current question is, are there Prometheus metrics that can be exported? Let me follow up with you on that one. If you go to, okay, if you want to put your email in chat, it is just going to panelists, and I'm the only panelist right now still. And I will follow up with you on that. Thank you very much, and I will follow up with you later this week, or probably today, frankly, on that. So the current question is, are there integrations with Kubernetes to run a workflow distributed across pods? We have a version that runs in in a container. We currently don't have that just out of the box available on the marketplace. We are working on that this summer and spring. I'm more than happy to work with you specifically on getting you a copy of that, but the full commercial release is not yet on the marketplace. I know that is a relatively popular topic that people are talking about. Our current approach to distribution and scaling is, well, using our marketplace image, but in general, we support SSL termination at the EC2 node, which means we can make an auto-scaling group at the load balancer and add or remove VMs dynamically. That would basically enable you to grow and shrink. We also now allow dynamic resizing of our VMs, where if you want to increase or decrease the amount of CPU in it, if you reboot, our marketplace image will automatically adjust all of the logging, JVM, and stuff to handle the new node size. But yes, Kubernetes is a vision that we're hoping to accomplish in Q2, Q3. Okay, thank you everyone for attending, and I'll see you next time.